Hello, and welcome to the fourth Geocast for Gaming. My name is Dino Bosselli, and I'm an engineer on the Google Maps Platform Gaming Services team. The objective of this series is to create a simple mobile game that uses Maps Gaming Services to create an interesting gameplay. In the first and second episodes of the series, we focused on the setups of both game client and game server, with an emphasis on the integrations with Maps SDK for Unity and Playable Locations API. In the third episode, we added all building blocks together and ended up with a fully functional server authoritative game running in our local environment. In this fourth video, we are going mobile. How do we get there? First, we'll add GPS support to our game so that it loads the real world around the player's current position. Then, we'll deploy the server on App Engine and expose our game REST API through a public-facing URL. Finally, we'll build the APK and deploy the app on mobile. Let's get started. Important: the client and server code for this game are available on GitHub at the following URL. Feel free to follow along. This game follows a hybrid design that uses geolocation for initializing the game world, and then allows players to move their avatar in a neighborhood without moving from their couch. To do so, we need to define the origins of our two coordinate systems, the 3D Cartesian space on one side and the Maps SDK coordinate system on the other side. This can be done by initializing the floating origin of the Maps SDK to the current GPS latitude and longitude. This will set the origin of the Unity world space to our real-world location. From that point, we'll keep loading and unloading the world relative to the avatar's position, while keeping the floating origin unchanged. To get the GPS location, we use the built-in location service provided through the Unity input class. The detection code, which runs in a coroutine, yields until the service is initialized and we have a valid location info. The game initialization resumes afterwards by invoking the callback provided in the function parameters. When we finally have a valid GPS location, we move the Maps SDK floating origin to the new coordinates, and also reset the position of the avatar before loading the map through the SDK. Now, let's handle a few edge cases. Whenever players navigate away from the app on their device, we want to stop the Unity location updates to save battery. We'd like to reinitialize our world each time the player resumes gameplay, as they might have moved away from our initial position. This can be done in the Unity built-in on-application-focused event. Also, we'd like to update the world's origin when players move far away from their current location. This can be done in the update loop by checking the distance between our current location and the initial floating origin. We want to be careful not to trigger a map reload every frame, since this will have negative performance implications. In the second video of the series, we briefly talked about the game server setup. At this point, we have a Spring Boot app using Gradle as a build tool with Cloud Firestore support. We have a supporting GCP project configured, which provides us with access to all services of the platform, and an API key for accessing Maps Gaming Services. To deploy the game server on App Engine on this GCP project, we need to update our configuration files. The base Spring Boot app cannot be simply packed into a jar file and copy-pasted into Google App Engine. It requires some modifications. In a nutshell, we'll make some changes to our build.gradle file to provide support for App Engine. Then, we'll authenticate to the GCP project. Luckily, this can be done easily with the Google Cloud SDK shell. We provide deployment instructions to App Engine through a YAML file and build a boot jar file. Finally, we'll deploy the game server on App Engine and test the deployment with our game client. Let's review the steps in details. First, let's configure our Gradle build file. The Google App Engine service uses Jet as a web server, but Spring Boot uses Tomcat by default, so we need to update the build file accordingly. We'll exclude the Spring Boot starter support for Tomcat and replace it by a Spring Boot starter dependency for Jetty. We'll also need to include support for App Engine. Adding all needed plugins and dependencies in the build file enables additional tasks for an easy deployment to App Engine. Interacting with the GCP project environment is easier with the local installation of the Google Cloud SDK shell. There are several ways to install gcloud in your environment, and the following URL provides some options. Once the SDK is downloaded and initialized, we can set the default project and retrieve application credentials in order to test our app locally. We need to provide deployment instructions to the App Engine service so that it knows what to do with our application. This is done in a YAML file. The YAML file will be placed under the src main App Engine folder. In our case, we'll only indicate that we have a Java 11 application and that it should be deployed onto an F1 instance. That's more than enough for this demo app. We'll also provide the entry point to our Spring Boot executable jar. And after the deployment is successful, we can test the game server by configuring the URL used in the client app. Now that we have a remote server, we can deploy the client app on mobile. Let's make sure that our Unity project is configured for the Android platform and that our main scene is listed under the scenes to build. Then, we set the supported orientation in player settings and the package name. This demo is meant to be experienced in landscape mode. We can leave all other values to their defaults. In order to build on device, we'll need to enable USB debugging. This can be done by tapping 7 times on the build number located on the About page, then by going to the developer options located under the System group and enabling the USB debugging flag. We're now ready to deploy a build directly on device. With the phone connected to the development machine, we can select it directly on the build settings dialog screen in Unity. Another option would be to build the APK in Unity, then deploy on device with the ADB command line tool. Finally, we just need to click on the build and run button to deploy and run the game. At this point, the game runs on mobile and is connected to the deploy server, but the game is still loading the map at our fallback latitude-longitude. We have one more step to perform before we can actually play in the world around us. We need to enable the location service for this app on our device. To do so, we turn on location and grant our game app location permissions. We can now reload our app and play in a neighborhood. Note that in a production environment, we would probably include this permission in the Android manifest file, and this will trigger a permission request while running the game for the first time. Et voilà! And that concludes the video series on how to create a real-world game with Google Maps gaming services. Let's recap. Over the course of 4 episodes, we've created a simple front-to-back third-person mobile game that uses the Unity Maps Gaming SDK and Playable Locations API to create interesting gameplay. The first and second videos focus respectively on the game client and game server setup, while the third video highlighted the integration between the two tiers. Finally, this video, the fourth of the series, focused on the geolocation aspect of the game with the deployment of the client app on mobile and game server on App Engine. You now have all building blocks to create your own real-world games, and we can't wait to see what you'll do. Thank you and happy coding!